Hello students, we'll continue the previous class where we are discussing fringe width expression. Fringe width expression. Okay, based on the Young's double slit concept. Here in the fringe width expression, we have taken a diagram which has, I hope you can see this diagram. Screen and two slits A, B. Distance between the slit and the screen is taken as D, and at the center we assume to be have a bright fringe at the center O, and the wavefront from the slit 1 would have made the point P. Similarly, from the second slit also the wavefront would have made the same point, since the wavefront has to, both the wavefronts has to overlap, and the distance between the slits is a small d. And one more point that we have discussed in the previous class is the point O represents the central bright fringe. The very next fringe is at a distance of x at point P. Like that we have assumed with respect to the bright and the dark fringe concept. And here I have shown like Q and R points we have taken. Otherwise, any other points also you can take. The slits with respect to the center is equally divided, or we can say the distance from the central bright fringe or the center to either of the slits, the distance is d by 2 d by 2, whereas the d small d represents slit width, that is the distance between the two slits. And from this diagram we came across with the two major equations, that is, one is bp square equals to, bp square means from this triangle bpr, from this triangle bp square is equals to, like we have taken br square plus pr square actually, where pr is equals to po plus or, which is equals to x plus d by 2. Hence bp square equals to, we can write br square is capital D plus x plus d by 2 whole square. And one more from the first triangle APQ, either the first one is AP or next one is BP. Anyhow, we have to take AP value in as well as BP value. Similarly, AP square we have taken from this diagram, that is this triangle, is AQ square plus PQ square, where PQ equals to PO minus QO. PO minus QO. PO is X minus D by 2. Hence, AP square equals to AQ is nothing but capital D, which is D square we can write, plus PQ square is X minus D by 2 whole square. So these two equations we have discussed in the previous class. So this was the equation 1 and this was the equation 2 in the previous class. And now what I am representing is a line drawn from the point A on the line BP, which meets at this point. Let it be C. Now we can see AP and BP, they may not be equal, so that AP and CP are equal. Of course, there is not so much of difference between the AP and BP. In this diagram, it can be seen like a lot of differences there, but actually it won't be, because these two slits what we have considered, they are very small gap we have between the two slits, so that the ray or the wave which is coming from the A and coming from the B have the path difference which is very less, or else we can say that the distance that AP and BP, they are almost the same, but even a small variation is there. That's what we calculate, like BP square minus AP square equals to. So BP square is this one and AP square is this one. BP square is D square plus X plus D by 2 whole square, as it is I will write X plus D by 2 whole square minus AP square is D square plus X minus D by 2 whole square. D square plus X minus D by 2 whole square. Now, if you go on expanding this, as it is D square we get plus, then very simple formula, A plus B whole square, which is X square plus D square by 4 plus 2 times of X into D by 2, which is XD only. 2 and 2 this cancel, minus of this one now, D square plus, because this is minus of from this BP square minus AP square, A minus B whole square, X square plus D square by 4 minus XD. 2 and 2 again get cancelled. And now if we continue the same, D square plus X square plus D square by 4, and next plus XD minus D square minus X square minus D square by 4, then whereas minus into minus plus XD we get. Here almost all the terms will get cancelled except the XD, plus D square minus D square plus X square minus X square plus D square by 4 and minus D square by 4. Remaining values is XD plus XD, which is 2XD we get, where the value is BP square minus AP square. So this one can be written in terms of like A square minus B square value, that is BP minus AP into BP plus AP, which is equals to 2XD, as it is we are writing. This BP minus AP will gives you the path difference. BP minus AP, this one will gives you the path difference delta. Whereas this path difference, it means, as I told, that the slit width, the two slits A and B, in the diagram they may look very far away from each other, but in practical the two slits are very close to each other, such that there is no lot of difference between the distance of AP and as well as BP. They are almost the same, but even then there exists a path difference. Hence, for our convenience, what we can take BP may equal to AP. Under such condition, BP plus AP will add up, and we consider that the P is very close to O, because in the fringe weight or in the fringes, interference fringes, alternate bright and dark fringes, what we obtain, these alternate bright and dark fringes, they are very close to each other. It is just like the fine weaving of a cloth. When you look at into your cloth, it may be your handkerchief, or it may be your own cloth. From the far distance, the cloth looks very plain. But when you see the cloth keeping very close to your eyes, you can see the fine weavings. The small weavings are the thread, the small threads. It has been weaved one in another. So there is a small holes like pores we can see in the cloths. Every cloth. So likewise, the distance between the two slits we have to imagine. Because to get the interference pattern, we have a certain condition, and that condition is two sources which are to be supposed to be superposed must be coherent, and keeping one source here, another source is here, it is not possible to produce a coherent source. Or using the same monochromatic source like sorry, one laser light here, another laser light here, and these two laser lights cannot be give interference pattern even though they overlap, even though they superpose each other, because the condition what we require for the interference, that the sources must be coherent, may not get satisfied completely. Okay, so that the two sources which are to be considered as coherent, they should satisfy all the conditions for coherent sources, then only the interference is possible. And hence P is very close to P O. It is just like if it is considered as a central fringe O, the next fringe is very next to this one, either this side or that side. It is just like the fine weavings of the thread for a cloth. When you look at into the handkerchief, the weavings that you can see, between each and every weaving we have a small pores. Okay, between two pores we have a single thread. It is just like this we can see the weavings in the cloth. Still it is very large. You don't have such kind of the cloths over here. Okay, so that still the cloths are very fine weaved cloths. Actually, they are. Each single line, when you consider both on either side, we have a small holes. Okay, those two holes can be considered as, or can produce the sources from a single monochromatic light, which can be a monochromatic. So that the point P is also considered as very close to O. Only to explain, we have taken the example of this diagram, keeping the P away from the O. So that if it is very close to P, sorry, O and P are very close means, so this point of P lies exactly at O. So that the distance from the A to this one and B to the O, it is the same, that is D. Hence, keeping the path difference as it is, BP minus AP into BP plus AP is nothing but D plus D only, which is equals to again 2xD. If I expand still, that is BP minus AP into 2D is equals to 2xD, where 2 and 2 get cancelled. The next is only BP minus AP will be left, which can be written as BP minus AP equals to XD divided by capital D. This one. This comes to the RHS side as a denominator. Whereas this BP is considered to be BP minus AP is path difference. Therefore, BP minus AP we consider as path difference delta. Hence the above equation delta can be written as xd divided by d. Consider this equation as equation 3. Now we got an expression for path difference of the interfering waves or interfering pattern. Path difference, and we already discussed the condition for constructive and destructive interference in terms of path difference as well as in terms of phase difference. Now we should take the help of this equation, equation 3, and substituting the condition for constructive and destructive interference. I mean to say conditions for bright fringe and dark fringe. Okay, in this equation. For that, little bit I will rub this diagram. I hope you can see up to till, okay, up to this portion. Now, now we shall discuss. Let us consider condition for bright fringe, or we can say that condition for constructive interference. According to that, delta E is equals to n lambda we have. Condition for constructive interference in terms of path difference. How did you got this one? Condition for path difference is, as we know that phase difference is equals to 2 pi by lambda into path difference, so that path difference is equals to lambda by 2 pi into phase difference, whereas lambda by 2 pi into phase angle is, that is cos phi is equals to plus 1 we have, and plus 1 is for, we have a condition, that is cos phi should be equals to plus 1, so that phi should take 0, 2 pi, 4 pi, and when you write the generalized formula, then we have phi should be 2n pi. So this condition we have, so that when you substitute here, then delta is equals to lambda by 2 pi into 2n pi. 2 and 2 get cancelled, pi and pi get cancelled, so that we have delta is equals to n lambda. That only we are taking the help here. Delta is equals to n lambda. But where to substitute? Because we know that if this is the central bright fringe, the next fringe is at a distance of x, according to the diagram, previous diagram which I have shown. At a certain point P or at a distance of x, one another fringe has been obtained, which is at a distance of x. Now, with respect to that concept, if I write the last equation as, since equation 3 can be implied as x equals to on cross multiplication delta d divided by small d we get, where delta is the path difference, x is the distance between center fringe to the very next fringe or any other fringe. For that, what I will consider, for nth fringe, we don't know exactly whether it is second fringe or third fringe or fourth fringe or 100th fringe, so that nth fringe I am taking. Like this fringes, if we go on putting, whichever you consider, that is a nth fringe. For nth fringe, we can write xn equals to delta value is n lambda, so that nth fringe is n lambda into d divided by d. Let us consider equation 4. Now it is nth fringe. Now one more fringe, if I want to calculate either this side or that side, if I want that side, n minus 1th fringe I should take. N minus 1th means if this could be the last, the previous one will be, imagine if you are calculating 10th fringe, then previous fringe will be 9th fringe. So how do I get 9th means it means one fringe is 10 minus 9 is 1. So one fringe value I will get. Hence n minus 1th fringe, for n minus 1th fringe we can write x of n minus 1 is equals to, in place of n minus 1 into lambda d divided by d. It is equation 5. So last fringe and last but one fringe. Next is we need only single fringe, and that single fringe is last fringe minus last but one fringe. That too the bright fringe I am considering, only bright, because the condition what I kept is for bright fringe, or we can say that it is for conditions for constructive interference. Now what I will do is last fringe and last but one fringe will give you the difference between the fringe, that is last fringe and last but one fringe. So that will give the single fringe value, that is width of single fringe. Why it gives only width? Because in terms of x I am calculating O is the center point, x is the distance, the next fringe I am taking, so that only the distance we are calculating, and that the distance is nothing but the fringe weight of the bright fringe. Hence, xn minus of xn minus 1 can be written as, xn is this one, xn minus 1 is this one. So xn value is n lambda d divided by d minus xn minus 1. That is n minus 1 lambda d divided by d. If I take LCM of this, so it is the d only, then n lambda as it is I will write n lambda into d minus lambda d into n is n lambda d, minus into minus plus lambda d into 1 is lambda d. So that plus n lambda d and minus n lambda d get cancelled. Hence, what do I get here? Xn minus 1, let xn minus 1 will be the beta, which is called, which is fringe width. Therefore beta can be written as, remaining is lambda d divided by d. This is the final, hence is the fringe width expression. Beta represents fringe width. Then we can say that the fringe width of interference fringes depends upon the lambda, depends upon the distance between the screen and the slits, and as well as depends upon the slits. How it depends? The fringe width directly depends upon the lambda, that is the first condition. Imagine if you are taking like violet to R, 7 colors we have. With respect to these 7 colors, wavelength of violet and wavelength of red color when you take, with respect to all these 7 colors, the wavelength will increase towards the red. Comparatively the violet, red color have more wavelength. If the entire experiment, Young's double slit experiment, if you are taking with the violet light or Vib Gaya or what we say, okay, if it is using the yellow light, if you are taking yellow bright and dark fringes we get. If you use orange light, orange fringes we get along with the dark fringes. If you are taking red light, red bright fringes you will get and dark fringes also you will get. Similarly any other color, but here what I mean is, suppose if you are using in the beginning as yellow color and there will be certain fringes are obtained. Suddenly if you change, or if the source is changed, instead of yellow if you go for the orange or the red, there is a change in the color will takes place. Along with that there is another physical quantity which is going to be changed, and that physical quantity is its wavelength, of course the frequency also, but in our relation we don't have the frequency concept. So that instead of yellow, if we use the orange, then wavelength is increasing. And as the wavelength is directly proportional to the fringe width, so definitely if the fringes are beginning for the yellow light, if we have a fringe of this much width, imagine for the yellow light, if we have a fringe of this much width, then suddenly for the orange or red light, the fringe width may be, so I'm talking about this width. Okay, this thickness we can say otherwise width. For the yellow light, this is the width. As we are going for orange or red, the fringe width increases because beta is directly proportional to the lambda. At the same time, what I am talking is only if the lambda changes. Simultaneously, if the d value also changes, then beta value also changes. If the d value also increases as the other two are increasing, if the small d is increasing means between the two slits, if I increase the slit width, which is inversely proportional, the beta value decreases. It is the same as that of no need of changing the color. If the entire setup of experiment to produce the interference pattern with a yellow light, if it is immersed in water, as we discussed in the ray optics, when the light enters from one medium to other medium, its velocity also changes and its wavelength also changes. It decreases usually. Then the fringes will start shrinking in the sense the initial fringe width is this one, the next fringe width may like this, only this much. Because light is the same, there is no change in the wavelength, but even then, why it decreases? Because in the water, because of that refractive index is different, velocity also changes and wavelength also changes. That is the reason why the fringe width depends upon wavelength of light used, distance between the screen and the slit, and the slit width. So these conditions whatever I have put, it is for bright fringe. Now let us see, as we have discussed in the last class, in the interference fringes, all the fringes, it may be a bright or dark, they have same fringe width, which means the width of bright fringe is same as that of the width of a dark fringe. So now let us discuss that condition also. Okay. Using the same equation, x value, that is x is equals to delta d by small d. Now let us consider condition for dark fringe. For dark fringe, which means destructive interference, delta equals to value is 2n plus 1 lambda by 2 we have. How did you got this one? Again, cos phi should be minus 1 we have discussed. Condition for destructive interference. When do you get the cos phi is equals to minus 1? Is for pi, 3 pi, 5 pi like this. And the generalized condition for phi is 2n plus 1 into pi we have taken, where n is an integer. 0 if you substitute, the phi value is, if it is n is 0, then phi value is pi. If n is 1, the pi value is, next is after the pi, next value will be 3 pi. If n is 2, next value will be 5 pi. This is a generalized condition we have taken for destructive interference in terms of phase difference. Whereas in terms of path difference, as it is when I write into phase difference is 2n plus 1 into pi. So that pi and pi get cancelled. The path difference condition is 2n plus 1 lambda by 2. This is the condition for destructive interference or to obtain dark fringe. So now with this condition, let x equals to, now we will substitute the values, that is a delta capital D divided by D. Here we substitute the delta value for nth dark fringe. For nth dark fringe, I will write xn is equals to delta is equals to 2n plus 1 into lambda by 2 comes into the denominator into D into capital D. In place of delta, I am substituting this condition. It is for nth fringe as it is. For n minus 1th fringe, then x of n minus 1 I should write. Then 2 times of n minus 1th fringe plus 1 as it is according to this condition. Okay. Into lambda into d divided by 2d. So that what I will get for this equation is n minus 1th fringe 2n minus 2 plus 1 into lambda d divided by 2d. Xn value I will get as, that is xn minus 1 is equals to 2n as it is, minus 2 plus 1 is minus 1. So that 2n minus 1 into lambda d divided by 2d I will get. Here it is. It is for xn minus 1. Now for the fringe weight, for fringe weight of dark fringe, that is beta again is equals to, I will take only beta, not the dark and bright as dark for D and bright for B. Only beta I am writing. It is xn minus 1. The xn value is this one. 2n plus 1 into lambda d divided by 2d minus xn minus 1 is 2n minus 1 into lambda d divided by 2d. 2d is the LCM. Now if I expand 2n into lambda d plus lambda d minus 2n into lambda d minus into minus plus lambda d. So that plus 2n lambda d minus 2n lambda d get cancelled. Here lambda d plus lambda d is 2 lambda d divided by 2d I will get, these two get cancelled. Hence the final equation for the beta I will get as lambda d divided by d, which is same as that of the bright fringe. Beta is equals to lambda d by d. Here also beta is equals to lambda d by d. So hence it is said that, or it has been now it has been mathematically proved that in the interference, bright and dark fringes will have equal width. There is no like plus or minus or anything like bright fringe may be, since it is a brighter, the width may be more. Since the dark fringe is dark, whose intensity is less, its width may be less. Not like that. With respect to this mathematical equation, the fringe width for bright and as well as dark fringe is same. There is no question of change of the fringes. Until and unless I will have all the fringes together, how long I will get the fringes on the screen, alternate bright and dark fringe, how long I will get the fringes, alternate and bright fringe I am talking about. All the fringes have equal width. All the means bright and dark fringes. And of course, one more condition I told, all the bright fringes will have same intensity also. Anyhow, dark fringes are dark. All these are the dark fringes. Wherever the gap is there, all those are the dark fringes. Dark fringes anyhow they are dark because their intensity is zero. But bright fringes have maximum intensity. But though from the first end to the last end, if you go or if you see, all the bright fringes will have equal intensity. There is no decrease or increase in the intensity of the bright fringe with respect to the fringe number. Which number fringe you are taking? For example, if this could be the center one, if you go to the right side or if you go to the left side, on either side of the center one, all the bright fringes will have equal intensity. It means there is no change in the intensity of the bright fringes in the interference pattern. Okay, intensity is same for all the bright fringes. Similarly, another condition is I'm talking about the intensity now. It is about fringe width. If you go for the bright fringe, whatever the thickness we have for the bright fringe, so with the same fringe width will exist for all the bright fringes and as well as for all the dark fringes. This one is dark fringe. Okay, even for the bright fringe and even for the dark fringe, width is same. It is not like, for example, this is a dark fringe and this is a dark fringe and these two are the bright fringe. Look at this, how it changes. Here is the gap. The dark fringe is only small gap we have. This is another big gap we have, another little bit small gap we have. And even I can write mention one more bright fringe like this. These structures are, this pattern shows the bright fringes are also unequal width. Dark fringes also have unequal width and the intensity also varies. This kind of the interference pattern is not possible. Only the, instead of monochromatic light, if you use the white light, then there may be fading of interference pattern takes place because it is a mixture of all the 7 colors will be there. But when you use the monochromatic light, then all the conditions what we have discussed so far for the interference will be satisfied completely, and that is the interference pattern is obtained due to the superposition of two coherent sources. That is first condition, or we can say when do the light or interference takes place. That is when the two coherent sources superpose each other, the interference exists or interference of light can be possible. Next, after the interference, how the pattern looks. All the fringes are of equal width. That one condition is there. Again, another condition is all the bright fringes will have equal intensity. Equal intensity. Bright fringes only I am talking because dark fringes have zero intensity. Definitely, they looks dark only. There is no intensity matters. Okay. Only for the bright fringe, intensity exists. Hence, intensity of each and every bright fringe in the interference pattern is same. And fringe width also mathematically we have proved fringe width for dark fringe or it may be bright fringe, it is the same. So this fringe width expression is asked for 5 marks. Obtain the expression for fringe width. It means either you can up to stop here up to bright fringe or you can extend it for dark fringe also, or else the question may be like show that the fringe width is same for the bright and dark fringe, then both you have to derive. Then we have to prove first and second both are the same. It means for bright fringe and as well as for the dark fringe, fringe width is same. So this is about the interference of light. Now the next concept after the interference is regarding the one more phenomenon that is exhibited by the light, that is called diffraction. Now one example for the interference that I can show you, or sorry, can you tell the example like soap bubble. Okay, soap bubble, the water bubbles. See, whenever the soap mixed water bubbles, when you see, we can see the shining, the different colors they will shine on the soap bubble. It is not looks exactly the white. Instead of that, some all the colors. It may be red. It looks like green, blue. All the 7 colors we can obtain. Otherwise, mixture of color. It is because of again the interference. That is the effect I am talking about. Effect. Again, we never get like alternate bright and dark fringes because interference is obtained due to the refraction of the light there. Even the reflection of the light can also produce. So the soap bubble is an example where the white light can do the interference. Okay, all the 7 colors which are obtained. So that is one example for the interference of light due to the white light. Okay, Similarly, we have a different methods of producing the interference of light practically. Okay, anyhow, that is not there for you, but even then, we have the condition is only we have to look at this beta value expression. How exactly the interference, whatever the theoretical explanation are there, with respect to that theory concept, we have proved the interference fringes do exist. They have certain width. They depends upon the lambda. They depends upon the distances. Distances mean the slit the distance and as well as slit and the screen distances. In the next class, we shall discuss the one more phenomenon exhibited by the light, that is diffraction.